we get S2 minus, that is sulfide ion, plus 4O3, giving 4O2 plus sulfate ion, or PbS plus 4O3, that gives 4O2 plus 4 PbSO4. Similarly, balanced equations for all the following oxidations can be prepared. So it oxidizes I minus into I2, but I minus changes into iodate in alkaline medium, nitrite into nitrate, sulfite into sulfate, arsenite into arsenate, manganate into permanganate, but this takes place in basic medium. And similarly, ferrocyanide ion is oxidized into ferricyanide ion. This too takes place in basic medium. Now, there is an important note carrying some points. So the first point is, in all the above redox reactions, O2 is one of the products, but O3 oxidizes SnCl2 into SnCl4 without any evolution of oxygen. That is 3 SnCl2 plus 6 HCl plus O3. The products are 3 SnCl4 plus 3 H2O. It is because the O2 liberated also oxidizes Sn2 plus into Sn4 plus, and hence it is consumed there in the reaction. The net ionic equation can be written as 3Sn2 plus O3 plus 6H plus, giving the products 3Sn4 plus 3H2O. Second, O3 does not react with ammonium salts, but it reacts with ammonia to form ammonium nitrate as shown below. So equations are 2 electron plus 2H plus O3. They give O2 plus H2O, multiply this by 4, then 3H2O plus NH3, forming NO3 minus plus 9H ion plus 8 electron, and NH3 plus H2O giving NH4 plus OH minus. Adding all these equations, we have the result 2NH3 plus 4O3, forming ammonium nitrate plus 4O2 plus H2O. Well, B type of reactions. Moist sulfur, phosphorus and arsenic are oxidized into oxyacids. For example, S plus H2O plus 3O3. They give H2SO4 plus 3O2. Similarly, P4 plus 6H2O plus 10O3 react to give 4H3PO4 plus 10O2. It reacts with carbon at room temperature according to the reaction C plus 2O3 giving CO2 plus 2O2. C. H2S plus O3 give H2O plus S plus O2 in aqueous medium. There may be a simultaneous oxidation in aqueous medium as 3H2S plus 4O3 forming 3H2SO4. However, in gas phase, the reaction is H2S plus O3 giving SO2 plus H2O. D. That's the reaction with dry iodine. The reaction is O3, first of all changing into O2 plus O, multiply this by 9. The subsequent reaction is 2I2 plus 9O forming I4O9. Adding these two equations we get 2I2 plus 9O3 forming I4O9 plus 9O2. I4O9 is an ionic compound, that is I3 plus IO3 minus whole 3, and it's known as iodine triiodate. Similarly, iodine third perchlorate can be prepared by dissolving iodine in cold anhydrous perchloric acid and then treat the solution with ozone. So the equation is I2 plus 6HClO4 plus O3 giving 2I ClO4 whole 3 plus 3H2O. E. Silver articles become black when brought in contact with ozone. The reaction is 2Ag plus O3 giving Ag2O, that's a black compound, plus O2. F. That is reaction with H2O2. Since H2O2 is less powerful oxidizing agent than O3, hence O3 oxidizes H2O2 into H2O according to following reactions. The first half equation is 2 electron plus 2 H ion plus O3 giving O2 plus H2O. And the second half is H2O2 changing into O2 plus 2 H ion plus 2 electron. Adding these two half equations we get H2O2 plus O3 forming H2O plus 2O2. G. It reacts with dry powdered KOH at minus 15 degrees Celsius to form KO3, which is known as potassium ozonide. So the reaction is 2 KOH plus 5 O3 at minus 15 degrees Celsius giving 2 KO3, in which K is plus and O3 is minus. It's a deep red brown solid plus 5O2 plus H2O. KO3, that is potassium ozonide, can also be prepared as KO2, that is potassium superoxide, plus O3, that gives KO3 plus O2. All these oxides, KO3, RbO3, CsO3, etc., are explosive compounds